I'm here with Dr. Romano to do the third part of the general chemistry video. He's doing the 2007 ADA general chemistry section.
Hi, I'm Dr. Romano. I'm professor of organic chemistry here at Romano Scientific and the creator of the Orgo-Man products and the author of the DAT Destroyer book. I'm continuing on now with the final leg of the general chemistry exam, which I'm going through with you, explaining to you step by step. It's very important that after you do this exam, you go back to the Destroyer and try the more challenging problems. Because I think that this exam is not that difficult. And the exam got a lot more difficult, but this will at least wet your beak and give you an idea of what was asked. So come on in and let's have a look. Now, on problem number 56, it says for this equilibrium, the solubility product constant is blank. Now, I wrote over here for you, the larger the KSP means the more soluble the salt. So what I did is I took the solid salt. The salt for the KSPs are always solids. It breaks up into two silver ions and sulfate. The KSP is nothing more than a KEQ. It's an equilibrium constant. It's the products over the reactants. Don't use the solid. You just use the aqueous ions. So it's going to be Ag, since there's two of them, you put it to the second power times the sulfate. And that's all there is to it. And that would be choice letter E. Remember, the only thing that will change the value of the KSP is temperature. In the Destroyer, we got some great problems on that. The next question, it says the concentration of silver ion and chloride in an aqueous solution in equilibrium with solid silver chloride are 1 to the minus 6 molar. What's the value of the KSP for silver chloride? Well, down here I wrote it out for you. You take the silver chloride, again, it's a solid, this is the solid, and it breaks into a mole of silver ions and a mole of chloride. So you write the KSP, it's the silver times the chloride. Since both of these are 1 to the minus 6th, you put them in, and that would be 1 to the minus 6 squared, choice E. All right, for number 57, I'm going to be using this equation. The delta H is the sum of the delta H of the products minus the sum of the delta H of the reactants. And what we have here, it says to determine the heat in kilocalories per mole for the oxidation of a mole of glucose. And they give you the reactants and the products and the heat of formation. The minute you see heat of formation, you know to use products minus the reactants. Notice oxygen is diatomic and it's in its standard state, so that's a 0. So all we're going to do is take the products, which is choice B. It's going to be 6 times the value of the CO2 plus 6 times the value of the water minus the value of the glucose, and there's only one of them, which is minus 297, and you just had to set that up. So very easy problem. Next question. Which process is accompanied by a decrease in entropy? A nice little trick that I show my students is think of this as a number line. Solid, liquid, gas. When you're going forward is a positive H and a positive S. Never forget that. So you need heat to do these transformations and you're increasing the disorder. All right, we're looking for a decrease, meaning instead of getting more ordered, it's getting less ordered. Sublimation of carbon dioxide. Well, go back to your little drawing. If you sublime something, you're going from a solid to a gas. So that means it would be an increase. It would be positive. So that's wrong. B is wrong. Evaporation, again, if you look here, evaporation means you're going from a liquid to a gas. So that would also be a positive delta S. But freezing of water, if you look here, freezing of water would go from the liquid to the solid. So that means the entropy would be negative. And therefore, you're decreasing the disorder. Shuffling a deck of cards, you're increasing the disorder, of course, so that would be positive. Heating something, you're adding heat, you're going to cause more disorder, so that would eliminate E. All right. Problem number 59, it says if a solution which is 0.50 molar in a compound X, decomposes for 5 minutes at an average rate of 0.40 molar per minute. What's the new concentration? Well, obviously, 0.50 you started with, you're decomposing, you're going to lose some. So choice E has to be wrong. It's got to be less than 0.50. Well, what I did is I went off to the side, and as you can see, I took the 0.40 molar per minute, and it's for 5 minutes. So 0.040 times 5, meaning you are losing 0.20 molar. Well, if you started with 0.50 and you lost 0.20, you end up with 0.30 molar. Easy enough. Next question. I say to you, for the reaction A plus B goes C, the experimentally determined rate law for the formation of C is given by rate equals K A B squared. Now, doubling the concentration of B does what to the rate? First of all, this is a third order reaction. A little trick is go to B and put in the number 2 and then square it. And that would simply quadruple the initial rate. Easy enough. Now, here's a hard one, 61. The following is a spontaneous oxidation reaction. Now, which is the best reducing agent? Now, the first thing I do is I look at the Cr2O7 minus 2, and it's going to Cr plus 3. Now, let's look at the oxidation state of chromium. Now, what I like to do is to say that the total charge is the charge due to the 2 chromiums plus the charge of the 7 oxygens. The total charge here is minus 2. So minus 2 is 2 chromiums plus 7 times oxygen is usually minus 2 in compounds. So minus 2 is 2 chromiums minus 14. You bring it to the other side. Plus 12 is 2 chromiums. And you would see that chromium is plus 6. So what's happening is we're going from a plus 6 chromium to a chromium plus 3. So therefore, chromium plus 6 is being reduced. If it's being reduced, that means that the Cr2O7 minus 2, the whole thing is the oxidizing agent. Now, if you go back, they're asking for the reducing agent. So that was not correct. If you go to I minus, and as you guys can see, forget the coefficients. It's an I minus going to an I2. So if I just put a 2 in front of it, anything that's diatomic is a 0. So you can see that this number is going up in number. It's going from a minus 1, it's going up. Therefore, it's being oxidized. And if it's oxidized, it's the reducing agent. So the answer is I minus. I did some tapes on this that I want you to make sure you look at, which explains about oxidizing agents and reducing agents. Number 62. Here's a great question. Given the following half cells, we give you the first one. It's got a positive voltage, and the second one, another positive voltage. What is the reaction for the E0? Now, whenever you do E0, don't look at the coefficients. I'll show you a nice little trick. I underlined the chlorine. It's on the left side here. Here it's on the right side. So that means we switch the sign. So instead of plus 136, it's minus 136. Copper plus 2 is on the left. Here it's on the left as well, so you keep it. So when you take the negative 1.36 plus the 0.34, that gives me the negative 1.02. Negative voltage means it's non-spontaneous. Answer C. Problem number 63. In which 2 compounds does nitrogen have the same oxidation number? I'll do A, and then you can do the rest. If you took a look at N2O3, each oxygen is minus 2, and there's 3 of them, minus 6. So this would be a plus 6 to balance it to 0, and there's 2 of them. So that means nitrogen would be in the plus 3 state. If you looked at HNO3, again, hydrogen is plus 1. each oxygen is -2. So therefore, you would see the nitrogen would be in the +5 state because you want to make sure that these charges balance to 0. So that was wrong. Why is choice B correct? If you looked at N2O5, this would be a -10 because each oxygen is -2 plus 10. So that means nitrogen would be +5. And I already showed you in HNO3 it's +5. So choice B, nitrogen would be +5 in both compounds. Next one, which is linear. I'm going to show you a great trick. We all know that water is bent. If you don't know it, you should know it. Water is bent. Since oxygen and selenium are in the same family, that means that these two would both be bent molecules. Okay, when you go into the destroyer, you can see how to do all the geometries, but I'm going to make this short and sweet. We remembered from organic chemistry that CO2 is drawn like this, where this middle carbon is sp hybridized, and this is a linear molecule. So I'm going to end this one really short and simple, but I want you to make sure you can draw out SO2, and I want you to make sure that you can prove to yourself that SO2 is a bent molecule. All right, but CO2 is linear, and that makes this really easy. The three isotopes of hydrogen are given. Now, the minute you're seeing 16O, 17O, and 18O, you would go to the periodic table, and you would see that the atomic number never changes. So I used to tell my high school students, when I used to teach high school kids, the atomic number is sacred. It never changes. So the correct answer is the three isotopes have the same atomic number, and therefore the atomic number simply means the number of protons. Notice if you subtracted these, you would get the difference, and that would be the number of neutrons. Okay, the grand finale. And finally, it says, here's the Lewis structure, and we want to know how many resonance forms there would be. Well, obviously, if they gave me this, I'm not going to put in all the dots to save some time, but each one of these O's gets a chance to be doubly bonded. So as you can see, I'm going to leave out the dots, if that's okay with you. Oxygen with a single bond is this. I'll put in the formal charges though. And then finally, we could put a double bond up here. So as you can see, the double bond could move to all these different spots, and you would be three different resonance forms. So notice the actual molecule is simply a combination of all these resonance forms. Number 67, the electronic configuration of this element is given. What is the number of unpaired electrons? 1s2, 2s2, 2p6, 3s2, and 3p2. What I would do is to simply count them up. 2, 4, 10, 12, you get 14. Now, the minute you see 14, this is silicon. So if they ever ask, what is it? It's silicon. And never forget, silicon loves to form 4 bonds, just like carbon. Well, as you can see, everything is filled up except for the 3p. Notice it says 3p2. Well, we all know there is 3 p orbitals, px, py, and pz. And there's 2, so each orbital gets 1, filling by Hund's rule. So what is the number of unpaired electrons? There is 2. And notice this would be diatomic. I'm sorry, this would be paramagnetic. Sorry about that. 68. Which property increases with atomic number among the representative elements of period 2? Well, when you're increasing the atomic number, you're going from left to right, and I hope you remembered, as you're going from left to right, the electronegativity is going to increase. The way I teach my guys to remember it, think of it as you're moving towards fluorine. Fluorine is very negative. Notice the radius would get smaller, gets less metallic. Boiling point will be decreasing because think of it as you're heading towards the noble gases, and melting temperature, of course, would also be decreasing. 69 is an easy question, which is the most ionic. Look for a metal and look for a non-metal. the most metallic is lithium, and the most non-metallic here would be oxygen. Notice these two would have the greatest difference of electronegativity. So it would be lithium and oxygen. And finally, in this reaction shown here, we want to know what is the second product produced. Now, all you would do to balance a nuclear equation, you have 13.7N. Notice it gives off what's called a positron. The upper left is 13, so you need a 13 here. You already have a 1, so this is a 6. The atomic number determines the element. So it would be 13,6 carbon. I hope that this gives you a good idea of what to look for and how to go about doing these questions. I'll do another video on this in the near future where I'll do another exam for you. All right, good day to you, and I hope you enjoyed this lecture series. Bye-bye.